This is the recording for Algebra 2, Notes 13-4, Exponential and Logarithmic Forms of Equations. Our objective today is I can convert and evaluate exponential and log functions. When we finish the notes, you should be able to answer the essential question, which is, how do I use exponents to evaluate logarithmic functions? So first thing we have to do is understand what logarithmic functions are. The definition that's given, you need to understand that b represents the base. And we have been talking about a base and an exponent, but now we're going to talk about the base of a log. N represents a number. Both the b and the n are positive numbers, and notice that b cannot equal to 1. So what this definition tells us is that if we are given a log equation in this form, and it is read log base b of the number n is equal to k, then we know that we can rewrite that as an exponential function. You have the base b is being raised to the exponent k, and that equals to n, which is the number you were initially taking the log of. One of the things to remember in both cases that b represents the base. So you need to remember that the base always stays the base. It doesn't change, whether you're writing it as a log or whether you're writing it as an exponent. So one of my favorite songs that's out right now is the song All About the Base. So way to remember this is it's all about that base, about that base. The base stays the same. It's all about that base, about that base. It stays the same. So we never change the base. The other thing that you can think of is when you look at this, when you're taking the log, it always equals an exponent. So when you take the log of a number, it will always come out to be equal to the exponent. So when you rewrite, you will see that you have a base raised to the exponent. So that's a couple ways that we're going to talk about how to memorize, how to use those two equations, or formulas, I should say. Recognizing how to change from logs to exponents and how to go from exponents to logs will help us solve problems like 2 to the power of x equals 7, because we know we can't raise 2 to any power and get 7, but logs, rewriting it as a log is going to help us. We're going to do that later on. Today we're going to talk about, well, how do I go from a log to an exponent? Because we're going to learn how to evaluate the logs. Hence our essential question, how do I use exponents to evaluate the log functions? So let's start with our first example. There are many different ways in which you can try and memorize these, and so I am going to show you two ways, and it is going to be up to you to decide which way works best for your brain. There are two methods that I'm showing today. One is going to be the label method. All the odd problems that I do in this recording is going to be used using the label method. The even problems, we are going to use what I call the circle method. So the label method is using the two equations and labeling our b, our n, and our k. It's in our first example, we have it as a log base 2 of the number 8 is equal to 3. So our b is our base. Remember, it's all about the base, and the base stays the base. So 2 is what our b is. When we take the log of a number, it always equals to an exponent. Oops. And in this case, our exponent, we're using the letter k. And then, of course, whatever number we're taking the log of, that's our n. So this is what I mean by we're going to label. And then my mnemonic that I use is bacon. If I know what my b and my n, my n, and my k are, then I can make some bacon, because I love bacon. So when I make bacon, this is saying that 2 raised to the third power is equal to 8. And sure enough, if I do 2 to the third power, that's 2 times 2 times 2, it does come out to be equal to 8. So when we're rewriting the logs, what we're really saying is, what can I take that base, or 2, what power can I raise it to, 3, to come out equal to the number we're taking the log of, which is 8. So that is the label method. Let's try that again. We're going to do problem number 3, because again, I want to do the odds as the label method, and then we'll go to the circle method. So the label method, I need to label my B, my N, and my K. And then I want to make some bacon. So B, K has to be equal to N. Our base is still the base. K is 0. And our N, or our number, is 1. And again, we can check. Any number raised to the 0 power is 1. So we do get 1 is equal to 1. So that's the label method. If you like that method, you can continue to use that method from this point out. I do want to show you another method. It's known as the circle method. And how the circle method works is we recognize the base is always the base, so we start with the base. I'll put my little helpful hint. I start with the base because it's all about that base, remember? But the base stays the base. So I start with the base and I'm going to circle around to the negative 2. So this tells me 2 raised to the negative 2 power is equal to, I continue to circle, and it's equal to the 1/4. Let me check that. If I take 2 to the negative 2 power, that is 1 over 2 squared, and 1 over 2 squared is 1/4. So it does check out. So again, circle method, doing number 4, we start with the base. The base is 3. I'm going to circle around to the other side. So 3 raised to the 4th power equals to 81. I can check. 3 times 3 times 3 times 3 does equal 81. Then yes, I know I wrote it correctly. So from this point on, you have your choice. Which method do you like? Do you like to label and then make some bacon? Or do you want to start with the base and circle around? The choice is going to be yours. I'm going to do the label method on all the odds from this point and the circle method on all the evens. I would like you to choose a method and then check to see if we come up with the same answer regardless of which method we use. So number 5, I need to label my B and K's. So 16 is going to be my base, 2 is my number, and K is my 1/4. So now I need to make my bacon. We'll get 16 raised to the 1/4 power is equal to 2. And that is all we are asked to do, is to rewrite your log as an exponent. Number 6, again, we're rewriting the log base 8 of 2. It says it's equal to 1/3. We want to write it as an exponent. So I start with my base, go to the opposite side. We get 8 to 1/3 is equal to your 2. Again, we are just rewriting our log as an exponent. Now in our definition, you will see it says if and only if, so it means if you're given a log, you can write it as an exponent, but that also means that if you're given an exponent, you can rewrite it as a log. So we're going to work our way backwards. So if I'm given a log, I can write it as an exponent, or given an exponent, I can write it as a log. This time we have an exponent and we are now going to write them in log form. So now we're starting off with our bacon because it's an exponential form. Again, my odds, we're going to do the label method, and the evens, we're going to do the circle method. Number 4, that's our odd. Let's label. B. This time we have bacon first. K and N. And now I need to change it back to the log form. So I'm going to put it in log base B of the number N equals to K. So we get log 2 is my base, N is 16, and K is 4. I've taken the exponent and written it in log form. I'm going to go on and do number 9 just to make sure you got it as far as the label is correct. So again, we're starting with the bacon this time. So we have B, K, and an N. I want to change it to my log form. And in the log form, the base is still the base. So the base is 32. The number is 2. And my exponent now is what it's equal to. So some people like to think that when I take the log of a number, it's always equal to an exponent. So this helps you out. If my exponent is 1/5, we know that the log of the number has to be 1/5. So that was 2 doing the label method. Let's try the circle method. The circle method, remember, we always start with the base. Does not change. The base stays the base. So if I start with the base, this is my base. This time I'm rewriting it log base 2. And I'm going to do the same method. I go across. It tells me what I'm taking the log of. And then it's equal to the exponent, -1. Number 10, let's try that again. My base is 8, so I start with the base. So log base 8. Go around 64 is what I'm taking the log of, and that's equal to the exponent 2. So notice how I'm completing the circle. Just like we did before, when we start off and cross over, those two numbers are on the same side, and then when I come back, that number is on the other side of the equal sign. So on number 11 and number 12, you get to decide which method you want to use, whether it's the label method or the circle method. I'm going to show the label method on the odds, the circle method on the evens. So let's go. This is the label method, so I'm labeling my bacon and now rewriting it. Log base 5 of the number 1 is equal to 0. Number 12, I'm using the circle method. My base is 6, so I have log base 6 of the number 6 is equal to 1. Now we spent time converting our exponentials to logs and our logs to exponential. We still haven't answered our essential question, which is how do I use the exponents to evaluate the log functions? So now that we know how to convert back and forth, let's actually use that information. So our first ones we're doing, we need to evaluate these logs without using the calculator. Log base 5 of 25, you might be thinking, I have no clue. But when I evaluate, what I'm doing is I'm actually solving. So I know this has to equal some number, I just don't know what that number is. And in the past, what we have used is the variable x to represent our unknown. So the first thing we're going to do is always to rewrite and use x for the blank. So I'm going to say use x for unknown. Then our second step is going to rewrite it in exponential form. So rewrite the log in exponential form, because we do know how to solve exponents. When you rewrite the log in exponential form, you can either use the label method or you can use the circle method. So I'm still going to follow my same pattern. Odds, I'm using label. Evens, I will do the circle. You are choosing whichever method you prefer. You're going to check to make sure we have the same thing. And then the last thing we will do is we will solve for x. So we've put the x in for our unknown, and now we're going to rewrite. So the label, this is my B and K. And now I want to find my bacon, which is BK, or B raised to the K equals N. And our base is 5. Our K is our unknown. That's our exponent. I don't know what it is, but it's equal to 25. This type of problem we know how to solve because I can ask myself, 5 raised to what power equals to 25? That's one way of thinking of it. Or the other way, which we've done before, is to say if I can rewrite 25 as 5 to a power so that they have the same base, then I know their exponents are the same. So 25 is 5 squared, which tells me if the bases are the same, then the exponents must be the same. So this gives me that x is equal to 2. Number 14, log base 4 of 64 equals something. I don't know what it is, so I replace it with an x. Now we rewrite the log as an exponential form. So circle method says I start with the base, go around, it's raised to the exponent x. It has to be equal to 4. Now I can solve for x. I recognize they have the same base, so that means our exponents must be equal to each other. Remember, if there's not an exponent shown, it has an exponent of 1. So this tells me that x is equal to 1. I'm going to rewrite in exponential form. So I know my base, I know my number, and x is going to represent the k. Rewriting, we get 4 raised to the power of x is equal to negative 16. So now when I try and solve for x, I'm asking myself 4 raised to what power can get me equal to a negative 16? Well, can I raise 4 to any power and get a negative number? And that answer is no. I can't raise 4 to any power and get a negative number, so this is not possible. Number 16, the log base 10 of 10 cubed. We must say it's equal to x, my unknown. Let's rewrite. Start with the base. This tells us 10 raised to the power of x is equal to 10 to the third power. My bases are the same. This means the exponents must be the same. So this tells us x is equal to 3. We just did 16, so 17. Log base 3 of 1/3. We don't know what it's equal to, so I set it equal to x. Let's rewrite it in exponential form. So here's my b in k. I'm using the label method. So it tells me 3 to the x is equal to 1/3. In order to find out what x is, we need our bases to match. This is 3, but this is 1/3. Recall that we can rewrite 1/3 as 3 to the negative 1 power. So I'm taking the 3, which was in the denominator initially, it has the exponent of 1, and I'm moving it to the numerator. So when I move it to the numerator, it will change the sign of the exponent. Now my bases are the same, so that means my exponents must be the same. This tells me x is equal to -1. 18. Log base 9 of the number 3 equals something. I don't know what it is. So let's rewrite it. We have the base 9 raised to the power of x is equal to 3. I need my bases to be the same. So the bases, one side is a 3, the other side is a 9. I recognize I can write 9 as 3 squared. So I've replaced my 9 with a 3 squared. This 3 squared is still being raised to the power of x. We'll remember our log function, not our log function, sorry. Remember your exponential laws, which says, hey, if I have an exponent raised to an exponent, I'm just going to distribute and multiply the two exponents together. The base will stay the same. So 3 stays 3, and I now have 2x is equal to 3. Exponent that's not shown is a 1. I now have the same base, which means the exponents are equal to each other. So 2x must equal to 1, and solving for x, we get that x is equal to 1/2. Our last problem, log base 16 of 1/2 equals something. I don't know what it is, so we let it be x. Let's rewrite it. So this is my b, my n, and my k. Rewrite my bacon, so we get 16 to the x power equals 1/2. This one is a little more challenging. Our bases need to be the same. One is 16 and the other is 1/2. I recognize I can write the 1/2 as 2 to the -1 power. And now I need to figure out how can I write 16 as 2 to a power. Well, 16 is 2 raised to the 4th power. It is still being raised to the power of x. So get rid of our parentheses by distributing. We can multiply the two exponents. Notice my base does not change. It stays at 2, so this becomes 2 to the 4x power is equal to 2 to the -1 power. Now that the bases are the same, our exponents must be equal to each other. So 4x must be equal to -1, and solving for x, x equals to a -1/4. You've just learned how to use exponents in order to evaluate logarithmic functions, and you had to convert your log to an exponent first. So as you close your activity, I'd like you to create a mnemonic to aid you in memorizing the method you will use in order to convert logs to exponents. This mnemonic is something that is just for your benefit. You need to write it on the bottom of your notes. Remember, we had two methods, the labeling method and also the circle method, but you need to come up with a way to memorize how to do one of those two methods. This concludes the lesson for 13-4.